Lesson 6.1, using equations to set up and solve for addition and subtraction word problems. The directions say write an equation and use it to solve the problem. Draw a model if you need to. So first, when you think of an equation, there's always going to be an equal sign involved in an equation. In this case, we're going to be given some information in the word problem that will help us solve for the unknown. And then we're going to use addition or subtraction to perform the calculations. Let's take a look at number 1, and you can see I've already marked up some of the clues. An orchestra played 3 concerts. Attendance for the first 2 concerts was 53,201. Let me pause there. That means if you total up the number of people who attended the first 2 concerts, you would get this number. What was the attendance for the 3rd concert if 78,433 people attended the 3 concerts altogether? So let's rewind. We've got the total for the first 2 shows. We've got the total for all 3 shows together. We're trying to use these clues to figure out how many went to the 3rd show on its own. So when I talk equations, remember, I'm talking about an expression where you have an equal sign. If I took the number for the first 2 shows, which was 53,201, and then I added a variable, which I'm going to use to represent the unknown, the number of people that went to the 3rd show, and I'm going to use C for concert, I know that this plus this is going to match or equal this. Now, I'm trying to solve for the value of C. What I do to one side of an equal sign, I must do to the other side of the equal sign in order for the equation to be balanced out. What do I have to do to the left side of this equation so that I'm just left with what I care about, which is C? Well, I've got to get rid of 53,201. How do I get rid of 53,201? I subtract it. So if I subtract 53,201 from this side, I've got to do the same to this side. I've got to subtract 53,201. Now I can set this up and solve it, and I'm going to do that in the space over here on the side. I need to line up my number by its place value. 3 minus 1 is 2. 3 minus 0 is 3. 4 minus 2 is 2. 8 minus 3 is 5. 7 minus 5 is 2. I can insert the comma. And I've got my answer. I've got the value of C, which represents the amount of people who attended the 3rd concert, is 25,232. Number 2, a baker was reworking his recipe for a cake. The original recipe required 3.5 cups of flour. The new recipe requires 4 1/4 cups of flour. What is the increase in flour from the old recipe to the new? Okay. In other words, what's the difference? Well, I know the new recipe is calling for more flour. And so if I'm trying to find the difference between the new amount versus the old amount, I can simply use subtraction. And I'm going to use a variable here, I for increase. How about that? 4 1/4 minus 3.5 equals I. Now I know when I am adding or subtracting fractions and mixed numbers, I need to start with a common denominator. The 2 denominators given here are the 4 and the 2. 4 is the larger of these denominators. Will the 4 work for the 2? Can I take 2 and multiply by something to get 4? Yes, I can. I can rewrite 1/2 as 2 over 4 by multiplying the bottom and the top by 2. But now, notice that the fraction 1/4 is smaller than 2/4, I need to borrow from the whole. When I borrow from the whole, the big whole number goes down 1, and that whole gets added into the fraction using this denominator. In other words, I'm going to add in 4/4 to the 1/4 that's already there. This becomes 5/4. 4 and 1/4 is equivalent to 3 and 5/4. Now I'm in a position to subtract, so let's set it up a little bit neater over here. 3 and 5/4 minus 3 and 2/4. Whole numbers cancel. 5/4 minus 2/4 is 3/4. And that's my answer. I've solved for I. 3/4 cups is the increase. Number 3, Georgia drank 2 bottles of juice. The first bottle is 11 and 5/10 ounces. How many ounces are in the second bottle if the total number of ounces in both bottles was 26 and 7/10 ounces? Okay. I'm trying to find out how much juice was in that second bottle. I'm going to use a variable S for second. The amount in the first bottle was 11 and 5/10. The amount in the second bottle is the unknown. That's what I'm trying to solve for. I'm going to use the variable S. It looks kind of like a 5. That looks almost identical to my 5, actually. So we'll just have to remember that that is the variable, not the number 5. 11 and 5/10 plus S equals 26 and 7/10. All right. Now, look at this equation. Look at what's on the left and look at what's on the right. I'm trying to solve for the value of S, the amount in that second bottle. What do I have to do to this side of the equation to clear it out so that I'm left only with S? Well, if you said we've got to get rid of the 11 and 5/10, you're right. I've got to get rid of it. So let's subtract 11 and 5/10 from this side, and let's subtract it from this side to balance out the equation. Now I can solve. Let's stack this vertically over here. 26 and 7/10 minus 11 and 5/10. Let's insert the decimal point right where it lies. 7 minus 5 is 2, 6 minus 1 is 5, and 2 minus 1 is 1. We get our answer for S, 15 and 2/10 ounces. Number 4, Jaquai made a garden 13 and 5/8 feet wide and 15 and a half feet long. What is the difference between the length and width of the garden? Since I'm trying to solve for the difference here, I'm thinking subtraction, and I'm going to use the letter D to represent the unknown. D, the difference, is equal to 15 and a half minus 13 and 5/8. I know that when I'm adding or subtracting mixed numbers, I must start with a common denominator. I have a 2 and an 8. The 8 is the larger of the 2. Will 8 work for 2? Yes, it will. Let's rewrite 1 over 2 as 4 over 8. Multiply the bottom and top by 4. Now, are we ready to subtract? Well, not so fast. 4/8 as a fraction is smaller than the 5/8. We've got to borrow from the whole over here. So when we borrow from the whole, the 15, the whole number will go down by 1. This will become a 14. And 8 over 8 will get added into the fraction to make the fraction 12 over 8. This is looking real messy. So now over here, we're going to write it in a cleaned up fashion. 14 and 12/8 minus 13 and 5/8. We can solve this. Whole numbers first. 14 minus 13 is 1. Fractions, the denominator stays the same in 8. 12 minus 5 is 7. We get 1 and 7/8 feet is the difference. Number 5, a container is placed on the scale and weighs 2 5/10 kilograms. The container is then filled with rice, placed on a scale, and weighs 7 85/100 kilograms. What is the weight of the rice? Okay, so the empty container, when you put it on the scale, weighs this amount. The container now that's filled with rice, placed on the same scale, weighs this amount. We're trying to isolate or identify what is the weight of the rice. Well, the empty container, and so I could use W for weight or R for rice as my variable. I'm going to use R. The weight of the empty container was 2 5/10 plus the weight of the rice altogether is going to equal 7 85/100. This is what I'm trying to solve for. How can I get this to be on its own? Well, I've got to get rid of this 2 5/10. If I subtract that out from this side, I've got to subtract that out from this side to balance out the equation. Now let's stack it vertically. Line everything up by place value. Notice that we have a gap here. What can we do with that gap? If you said fill it in with a 0, you are correct. Insert the decimal point right where it lies and solve. The weight of the rice is 5 35/100 kilograms. Number 6, 80 bottles of water were sold from a cooler on Monday. At the end of the day, there were 262 bottles of water remaining. How many bottles of water were there at the beginning of the day? Okay, let's visualize this. Visualize, I guess in this case, a very large cooler, and it's iced down, it's filled up with bottles of water. At the end of the day, this is the amount that's left. We're trying to figure out how much was there at the beginning of the day, and I'm going to use the variable B to represent that amount. We know that 80 bottles were sold during the day. Okay, so B is the amount at the start minus the number that's sold, 80, gets you what was left at the very end of the day, 262. Now, how can I, looking at the left side of this equation, get B on its own? If you said get rid of the 80, you're right. But keep in mind that we're not adding 80 to B, we're subtracting 80. So if I do a minus 80 here, that's going to steer me wrong, because now I'm going to be looking at B minus 160 equals 262 minus 80. I don't want to subtract 80 from both sides. I've got to add 80 to both sides. I want to make sure this is really clear. 80 plus B minus 80. This clears out this side of the equation so that we're left with just B, equals 262 plus 80. Let me say this again. Our goal was to take an action so that the only thing left on this side of the equation was the variable B. In the beginning, the equation had B minus 80. We are simply adding 80, doing a plus 80, so we can clear this out. But if we do a plus 80 here, we've got to do a plus 80 over here. Now we can line this up and solve it. Oops. And we get 342 bottles were there at the start of the day.